Hi, my name is Ashley Culver, and I'll be talking about ways to kill pathogens. And when I say pathogens, I'm referring to all microorganisms causing disease, excluding viruses. If I'm going too fast, go ahead and pause the video. I promise that I won't mind. And if you prefer to read the written script, I'll leave a link in the description below to its Google Doc. You're probably not surprised to hear that soap and water are effective at destroying pathogens, but do you know why? A cell membrane is made of a lipid bilayer, which can be broken up by the soap and rinsed away with the water. Any organism with a membrane relies on it to keep in or keep out certain chemicals. This chemical balance to maintain order within an organism is called homeostasis, and without a membrane, the organism cannot maintain homeostasis and it dies. I grouped hand sanitizer and rubbing alcohol together because they use the same thing to kill microbes: isopropanol alcohol. The alcohol kills germs by dissolving their proteins necessary for survival. Still, if the surface is visibly dirty, the chances of the alcohol penetrating through all the particles is unlikely, so using soap and water accompanied by plenty of scrubbing is a safer bet. Both bleach and hydrogen peroxide are antiseptics that destroy pathogens by oxidation. Oxidation is the process where one compound's oxygen atoms are incredibly reactive and they attract or steal electrons. Bleach and hydrogen peroxide rip the electrons from cells, damaging them to the point of being inactive or even completely breaking them apart. This is the method that you'll be using if you want to try out my lab on toxoplasmosis, which you can find on my website right here. Heat is one of the easiest and most common ways to kill pathogens, and it's the reason that we cook our food. Heat denatures the proteins of cells, and denaturing is the process of unfolding proteins so they can't function. No cells can survive without proteins. As you can see in the diagram, proteins undergo complex stages of folding to form a structure, the most complex being a quaternary structure. The primary structure is just a polypeptide chain or a string of amino acids. All functioning proteins have at least achieved the secondary structure, where hydrogen bonds form at certain points between the polypeptide chain, creating unique shapes like this alpha helix. When a cell is exposed to high heat, the hydrogen bonds break and the proteins lose their structure, rendering them useless, and the cell dies. And that is how it's done. Good luck, and may the destruction of pathogens be as easy as it was intended to be.